So welcome to the first session of the day. Thank you for picking this as your first breakout after the general session. So let me first introduce ourselves. My name is Tina Lam. I'm a group product manager from our VMware Cloud Provider program.
Yeah, hello everyone. My name is Budavari. I'm a senior staff technical product manager in our networking and security business unit.
Yeah. And then before we get started, right, the standard disclaimer. I have yet anyone that can recite it in its entirety, so if you don't, just please read it quickly. So let me first start it off the session is called NSX for Service Provider, which is usually not the focus of the VM world. But yet we have this session here. Why? Because service provider, we find that a very key strategic partner for VMware. Can I have a show of hands? How many of you are service provider here? Okay, great. Thank you for coming here, and thank you for being supporting us. The reason that we are thinking is so important as you guys, as our partnership with VMware is that our customer, your customer, are going through a really complex journey to this multi-cloud. Before it was on-prem and getting to the private cloud hosted by you, the hybrid cloud, but now the whole world also opened up into the public cloud, into multi-cloud. So it's quite complex, quite complicated. So many of them look to you to guide them to this journey. But you cannot do it alone, and that's why we have the partnership through the VMware Cloud Provider program to give you a framework and a platform to enable you to bring the customer onto your cloud, operate them efficiently, giving the services they want. And also, if they choose to go on to the public cloud and you want to provide managed service, we also have many different VMware Cloud products that enable you to help them manage the multi-cloud successfully. So that journey, we usually break it into the three parts. The first one is we help you to modernize your own cloud first. How you can utilize it to utilize our VMware Cloud Provider platform to make sure that your infrastructure is running as efficiently and operate as quickly as possible. That's one. But if some of you also want to move into an asset-light model, instead of operating your own infrastructure, want to leverage our VMware Cloud on AWS, we also have a lot of tool set for you to do that. And then lastly, for the true multi-cloud journey, then how we can help you leverage all of the VMware Cloud Provider services to manage your cloud, their on-prem as well as public cloud. This will be the final step of the journey. So with that, all of those networking is very important to all three of them. And that's why we are here. You are here to talk about NSX, how we can enable NSX to modernize your data center. So with that, let me go into agenda. We will talk about first give you an NSX overview. Many of you may have already deployed the NSX V, but we also will talk about a lot of that in the NSX T. Then there's use cases for both V and T in your own your cloud, in your own data center, what makes the NSX relevant for you. Then we will talk about that for the cloud, really specific to the service provider, how you can operate the NSX in a multi-tenant fashion. And then lastly, for some of you that already start thinking about NSX, NSX-T, how we can help you to adopt NSX-T or prepping yourself for the NSX-T transition. So with that, let me hand it off to Ray to start us off with the NSX overview.
Okay, thank you, Tina. Okay, so actually, I've been working on NSX as kind of a platform architect for the last 5 years, but actually before that at VMware, I worked on Vcloud Director. So this is an interesting session for me, a combination of things I worked on during my time at VMware. Let me ask everyone, how many of you are actually using NSX as part of your services today? Okay, excellent, very good. All right, well then in that case, I can go reasonably quickly through this overview of NSX, but this is where we're going to cover some of the NSX platform and differences between NSX V and T. The first thing I'm going to start off with, though, is explaining the role of NSX in, hybrid cloud or in your cloud services. And now I understand and admit I have a fairly biased view as part of the NSX product team, but we very strongly believe that NSX is the key to enabling hybrid cloud and cloud services. And the reason for this is much like the way that Vsphere abstracts your underlying server hardware from your VMs to enable the benefits of virtualization. Right? NSX runs on top of a cloud provider's network and abstracts the differences between that public cloud network and the on-prem, vSphere networking, which can typically be quite different. You might have overlapping IP address spaces, or you may not be able to support capabilities such as VM mobility, multi-destination protocols that enterprise apps rely on. So with NSX, what we're able to do is really treat the public cloud network as an underlay or a transport and provide the same visibility, compatibility, and services with vSphere networks that are used on-prem. So, another benefit with NSX is, as a software-based platform, anytime you configure these networking services, right, switching, routing, firewalling, VPN, NAT, DHCP, and many others, these can all be done without any changes at your cloud provider infrastructure layer. So this is why I say NSX is really fundamental to enabling this model of hybrid cloud networking. All right, now I have a few very quick words about NSX Data Center, which is the new product name for NSX. And when it comes to NSX, we have a common product name regardless of whether it's NSXV for vSphere or NSXT, because we really position NSX as one platform with a common set of capabilities, right? NSX is the platform that delivers software-based network virtualization, distributed services at the hypervisor as close as possible to the workloads with context, and everything is available through APIs and driven through automation. And then what we'll see is that the version that gets implemented will really be based on a choice and your requirements. So, it means that today the large majority of the customers and implementations will still have a fit for NSXV. But we're introducing NSXT targeted at specific environments and use cases. And I'm going to make sure this positioning or the use cases are very clear for each of these products. So we'll start with NSXV. As I said, it continues to be the lead product and is really focused on vSphere environments and architectures that require integration with other VMware solutions. So things like Horizon, AirWatch, SRM, Vcloud Director, and vRealize automation. So NSX for vSphere is a very mature platform. Right? It has a rich partner ecosystem with many, basically anyone that matters in the networking and security industry is integrated with and providing value on top of NSX as a platform. And it also has a feature depth in terms of multi-site capabilities that we'll talk about today, right? Rich security services, advanced microsegmentation and context awareness, service insertion and VPN. It's also the platform that's used in our hyper-converged infrastructure and VMware Cloud Foundation. And another important point I want to make is that VMware is continuing to invest heavily in NSX for vSphere. And there are a lot of new capabilities, some very relevant to service providers that we've just introduced in NSX for vSphere 6.4. And we also have an ongoing roadmap for the product as well. So, I said that we're investing still in NSX for vSphere, and actually 6.4 was our largest product release in terms of features and fixes, so a very significant engineering effort. It's also supported for a full 4-year life cycle until 2022. And some of the key highlights that we've added, as I said, it was our big release, and I think these are very relevant to service providers, is what we're calling advanced microsegmentation, looking deeper into the traffic and doing deep packet inspection, so we can do what we call context-aware firewalling, layer 7 firewalling. We've enhanced our identity firewalling and our application rule manager to make it even easier to implement microsegmentation. We've added a lot of rich operational capabilities, right? We've started moving to the HTML or the H5 UI. We've added an upgrade coordinator and many other dashboards to make operating NSX at scale, like service providers do, even easier. And we've also invested in core services. VPN has had a lot of investments. We've added layer 3 multicast support, improved failover times, and much, much more. So a couple of these key features that I wanted to highlight for service providers are context-aware firewalling and VPN. And what we've done is we've built on the foundation of microsegmentation with distributed firewalling and added essentially more application context. So basically more context, and to make it even easier to implement microsegmentation. So now, with basically building upon the distributed firewall and the layer 2 to layer 4 5-tuple firewalling we've had traditionally, we've added, as I said, layer 7 inspection for traffic. And so this includes identification of over 50 server-side applications, and in each release we're adding more and more app IDs that are really targeted for east-west traffic and VDI. So we still leverage and integrate with partners for the richer feature set for north-south traffic, but now NSX can handle layer 7 distributed firewalling for east-west. So basically we look deeper into the packet and provide protocol and version identification. So we can tell you, for example, SSL and TLS versions and identify the actual applications. And you can now use this context in the firewall rule table, in Service Composer, in flow monitoring, and in your application rule manager to build a much richer security policy. So better security, simplified policy. I mentioned that VPN has had a lot of investment, and this was really primarily driven for service providers and hybrid cloud, right? VPNs are very commonly used to establish secure connectivity between on-prem and a service provider. So we've enhanced it significantly in NSX 6.4 and some of the subsequent maintenance releases. Basically, we have IPsec VPN, which is secure L3 connectivity, so routed connectivity. And we've added things like IKV2 support, SHA-256, responder-only mode. So in the past, we would initiate and respond. Now there's a more deterministic mode of respond only. We've surfaced a lot of additional statistics and operational data to make troubleshooting and reporting of VPNs easier. That's relevant as providers if you want to provide this data back to your customers via our APIs or maybe your own integrations. You can now export the remote site configuration in one API call, making it easier to configure remote devices. We've enhanced our testing, so we test now against all of the common VPN gateways. And in fact, we just released NSX for Vsphere 6.4.2, which adds two big features. Our IPsec VPN was policy-based, right? You had to configure your traffic selectors manually, local networks, remote networks, and then as new networks were added, you had to go and update your VPN configuration. That worked pretty well for static environments, but we actually have just added a route-based VPN implementation using VTI, virtual tunnel interface. So now you can use BGP to dynamically advertise your networks over IPsec VPN, which is nice. And that also allowed us to do tunnel redundancy, so the idea of active and standby tunnels with automatic failover between them. So you can see, VPN is getting a lot of investment in NSX for Vsphere. We also have a L2 VPN offering where you can extend networks between local and remote networks across an SSL tunnel. So this is obviously very relevant when it comes to moving workloads from on-prem to a cloud provider and back. And we've invested here as well. So we've added high availability for both managed and unmanaged edge options, and a lot of additional statistics and operational data. And actually, Tina mentioned a disclaimer at the beginning, so as a small preview of something else we're working on is I said that this is over an SSL transport, which is great, right? SSL goes through pretty much every firewall policy known to man, but it is a bit, as it's TCP based, it's a bit more latency sensitive. So as the latency increases, performance goes down. So we are also working on different transport options, a UDP based one that's less sensitive to high latency as well. So as I said, continuing to invest in the platform. When it comes to the use cases, really it's been about strengthening our core use cases and adding more and more capabilities. You can see that that NSXV is really a fit for all of the security, automation, and multi-site use cases NSX for, as long as the underlying platform is Vsphere. It also enables hybrid cloud solutions like workload mobility and disaster recovery, where you have Vsphere on-prem and in the cloud. You have that image compatibility and APIs. All right. So, why have we introduced NSXT, particularly when NSXV is still a growing product? It has such a rich feature set, and then we're continuing to develop on it. Well, as in the NSBU, we also know customers are starting to embrace new technologies like containers. Workloads are running, or the number of workloads running in public cloud increases. And so it's important that NSX, can expand to offer all of its networking and security services natively within these new environments. So this means that, as NSX, we need to prepare for environments without Vsphere, but very critically are still optimized and the best fit for Vsphere. So, this involved some platform changes to work independently of vCenter, which is really why we introduced NSXT and our next generation networking and security platform. So a really key point is that NSXT, and is still the only kernel level integration with Vsphere. So the great things the distribution and context that we have with NSXV is still carry forward, right? But it now also works across multiple hypervisor platforms, containers, native public clouds like Azure and soon AWS. And actually, we also have future plans for bare metal support with NSXT. So it's all about bringing the value and benefits of NSX across all different types of workloads and environments. In addition, I'm going to, because I think it's very relevant to service providers, talk about how NSXT leverages some of the latest offloads and hardware accelerations to really scale virtual networking to new levels of performance and provide very fast convergence times. Important as you're looking at running, VNFs and network functions as part of your cloud offerings. So in the interest of time, I think this is better as a reference slide, but I wanted you to see that the platform capabilities of NSXT and understand there's already a very rich feature set there. So, some of the key highlights here are, that we do support multiple hypervisors today, ESX and KVM. Container support is generally available. We're supporting Kubernetes and distributions of Kubernetes, so PKS, Red Hat OpenShift, and also Pivotal Cloud Foundry. we work independently of vCenter, but we can leverage vCenter as a compute manager for lifecycle management and to make operating your environment easier. And we also have a solid set of distributed services. So we still believe that where we can distribute services like switching, routing, and firewalling, the hypervisor, the endpoint is the best place to do that, and we've carried that forward with NSXT. And as you can see, we have a number of services available. We're still using overlay networking, and we're going to talk about DPDK edges actually in more detail. Then when it comes to automation, operations, and troubleshooting, we've really built upon all of the experience that VMware has from 5+ years of having a mature networking and security virtualization solution deployed at scale across thousands of customers and built that into NSXT from day one. So, everything, again, is API-based, but we've actually enhanced it so that the API is self-generating, right? It's generated in a JSON format using Swagger. We have all those tools, upgrade coordinator, port mirroring, port connection tools built in on day one, and full monitoring and statistics. So again, it's already quite a feature-rich platform. So I said I would try to also make the use cases very clear, and that's that NSXT has a very targeted set of use cases really around containers and developer clouds, native public cloud where there is no vSphere hypervisor, and multi-hypervisor environments where you have ESX and KVM, and OpenStack environments. So, all right, with that, given you're all have that background in NSX, I'm going to I'll move on right into the NSX use cases for service providers. And this is where, we think NSX, has a key role in allowing you as service providers to enable differentiation and integration with other services you provide. So, NSX functionality can be consumed through a cloud management system, and Tina will talk in detail about how Vcloud Director does this. And we think that's a lot of value VMware can provide with out-of-the-box integration. But many of these use cases can also be consumed out of band as service provider or provider managed workflows as well. So this enables you to deliver additional value-added services to your consumers, differentiating you from other providers or integrating with the other things that you do very well. So it could be, network-based services that you have. It could be storage solutions. It could be security-based offerings. All of the above are things that we can do. And you can always automate these for self-service or rapid provisioning. So here's a table of some of the use cases I'm going to walk through. But actually, in the interest of time, I'm going to jump straight in. So we talked about L2 VPN just in terms of our VPN investment. But just for those of you who are not familiar, it is a feature provided by our Edge Services Gateway. And as I mentioned, it provides a secured network extension over any IP network. So what we do is we run NSX Edge in one location as a client. Let's see, do I have a pointer? So we run an L2 VPN client, and then a second NSX Edge, generally on the provider side as a server. And obviously the server will terminate these SSL connections from the client. And this provides us the ability to extend any combination of legacy VLAN back networks or newer VXLAN logical switches across different environments. So this allows you to move workloads from on-prem to cloud or back, retaining the same IP address. We also support with our L2 VPN very flexible topologies. Gateways could be on-prem, in the cloud, or actually in both with egress optimization. Another important thing we've done with L2 VPN is that we actually unbundled the client. So you can actually deploy the client with NSX management, and there are some benefits to that. in terms of visibility and API-based automation. But you can even deploy it as a standalone virtual appliance. So now, as long as your customers are running Vsphere, basically ESXi 5.0 or newer, we can support this network extension so they can, do things like cloud onboarding or disaster recovery, even without a full NSX footprint on-prem. And in fact, this unmanaged or standalone edge is something we're continuing to invest in. So we support L2 VPN today, but we're going to bring more services like IPsec VPN, edge firewalling, and load balancing to this standalone edge as well. So I think this is, there's a lot of value here with L2 VPN, just given the fact that when you have vSphere on both sides, you can support VM mobility between on-prem and cloud. Okay, another service that I actually worked on as the architect for is cross V Center Nsx. And this is a way of providing or extending NSX networking and security across vCenter server boundaries. So we've actually had this capability for a while. We introduced it in NSX 6.2, but have enhanced it in 6.3 and 6.4. And I think why it's relevant to service providers is that we have actually a number of providers who have cloud services where, customers has their own on-prem data center, but they actually leverage a cloud provider or host their second site at a VMware Cloud Provider Partner. And then they can use cross V Center Nsx to build up, as long as they basically meet these technical requirements of 150 milliseconds round trip time latency between data centers and can support 1600 byte MTU. They build up their NSX infrastructure at both sides. And then what you do is actually create a primary and secondary relationship between the NSX manager on-prem and the NSX manager running in the cloud provider's infrastructure. Right? And as you build out, you still have your local, obviously your local workloads, your local edges. But this allows you to actually create a universal transport zone that spans across both sites. And this enables you to now build essentially universal logical switches and distributed logical routers that provide L2, high-performance L2 that spans both sites, distributed routing for optimized east-west routing with multi-site awareness, and universal distributed firewalling for a consistent security policy that actually moves with your workloads between on-prem and the cloud provider, right? So in this model, as a cloud provider, you can truly become an extension of the customer's on-prem data center with all of the same networking and security services. So huge value there. Another great use case for NSX in service provider environments is to secure network-based provider services. So here, as a provider, you might provision, let me build this out quickly, one or more networks to provide services like monitoring, patching, software management or backups. And then we leverage the NSX distributed firewall and spoof guard features to enforce security and isolation by restricting communication across tenants. So the only traffic that's permitted are those service provider network-based services, and you can now provide these in a multi-tenanted fashion while any cross-tenant communication can be blocked. This is what you can do when you have a firewall policy enforcement point at the VNIC of every workload in your environment. Okay, in addition, I think, the people here are familiar with NSX, and I talked about the rich ecosystem we have, right? We support a policy-based approach to services. And here, they could be native services from NSX, like our distributed firewall, or that rich third-party ecosystem for things like antivirus, anti-malware, next-gen firewalling, IDS, IPS. So basically, these services get registered with NSX, and you can have different services or multiple services registered for even the same type of feature if you want. So this gives you a lot of flexibility and choice in terms of which services you might offer as value-added service to your customers. But basically, what you then do is use NSX Service Composer to choose which workloads leverage these specific value-added services. So the workflow here is quite simple. Basically, you use NSX security policies to define how security services get applied, and then there's a dynamic membership criteria using NSX security groups to apply these services selectively. So either a provider or a tenant gets full control on which VMs require or get these additional value-added services that you provide. So it's a great way of going above and beyond just providing base connectivity and base firewalling and providing, additional services and capabilities. All right, now a couple of NSXT specific enhancements that I think are very relevant for service providers. So particularly when you're running very performance sensitive NFV workloads. And the first is that I mentioned we introduced a new edge in NSXT. So this is our next generation edge that gets we refer to them as edge nodes. And the first difference is that we offer the edge node in two form factors, right? Bare metal in addition to virtual machine. And both of these form factors leverage the latest DPDK or offloads for high performance. So this allows us to provide excellent performance, forwarding of millions of packets per second, even at small packet sizes. Obviously, we have a lot of performance data that we can share with you on just how well we've been able to scale software-based networking with NSX. But basically, I don't have a lot of time, and I love to get into these details, but DPDK is a data plane development kit, which is really a set of libraries built around accelerating packet processing workloads. So it's all about how do you send and receive packets using the minimum number of CPU cycles. And the key here is moving away from a poll-based mode to an interrupt-based mode. And this allows us to, again, use less CPU cycles and handle traffic, dedicate CPU and network functions specifically for network packet handling, right? And it also means performance increases linearly as you add resources. So, basically, I mentioned we have the three different form factors, small, medium, and large. They're actually just double. So small footprint, 2 vCPUs, 4 vCPU for medium, 8 for large. Performance doubles as well as you add more resources. This is another huge benefit of leveraging DPDK. And DPDK now also allows us to prioritize traffic, real-time traffic, and support BFD or bidirectional forwarding detection for very fast convergence. So again, now with the NSXT Edge on bare metal, we can support sub-second convergence if you tune down the BFD hello timers. And actually on the VM form factor, it can be 3-second convert or failover, well within the limits of what's acceptable for most applications. So again, based on your requirements, you can choose VM or bare metal form factor with high throughput and extremely fast convergence times, really addressing one of the last remaining pain points with virtual networking. We also took the benefits of DPDK. So first, we've had these in the edge for layer 3 and above, and we've brought them in our most recent release to layer 2 forwarding as well. So what we saw is that the traditional ESX networking stack certainly has very good performance for your typical enterprise data center applications. But there was a higher CPU cost for packet handling because we had processing, we needed to process things using what we call I/O chains in our VDS. And we had those interrupt mode VM kernel drivers for networking. So we had to interrupt the CPU to handle network traffic. Which is, again, generally it's fine, but when you're handling millions of packets per second, or you need real-time like NFVs do, that could be a problem. So with NSXT and our next generation virtual switch, we've introduced what's called an enhanced data plane mode. And this is basically a DPDK-based NSX vSwitch for layer 2 forwarding. So we're already leveraging DPDK for layer 3 and above via the edge. And we, now enhanced data path mode basically allows us to use those DPDK libraries, export them to ESXi drivers at the VM kernel level, and get all those benefits of interrupt-based network handling instead of pole-based for virtual switching as well. So this really gives us a massive performance step. So with the latest Vsphere version of Vsphere, we see a 3 to 5x performance improvement in enhanced data plane mode, all with lower CPU overhead. So you can see this is a big step forward now in virtual networking for telco and NFV workloads. It really ensures that Vsphere and NSX is faster than any other virtual switch, and that we're the best platform for these service provider workloads. All right, last use case I'm going to talk about is containers. So there are a few sessions on this topic. It's a big topic, but so I'm only going to touch on it very briefly, because we know that many service providers are starting to offer containers and PaaS to their customers as well. And what we see is containers, right? They're great for developers. They introduce a lot of flexibility, allowing them to move to microservices-based architectures, deploy, or develop wherever they want, and then deploy anywhere decoupled from the infrastructure. But they introduce a lot of challenges for networking and security teams, particularly in multi-tenant service provider environments. There's limited security, visibility, and ability to support flexible network topologies. So what we've done, with NSX is we've ensured that the same benefits that we introduce for virtual machines carry over for containers, so that you can use actually one platform and the same operational model for containers as you do for your virtual machines. And how we do this is in a plug-in based model. So essentially, we do this by natively integrating into container orchestration frameworks using an NSX container plugin that interfaces with something called CNI, or the Container Network Interface. And this is a standard API between the container runtimes and NSX. So it's a cloud-native computing foundation project that supports Kubernetes, Pivotal, and other container orchestration tools. And as I said, it allows us to use a plug-in model to provide networking and security services. Basically, our NCP provides or dynamically creates logical networks, security for containers, and so networking, security, and load balancing. As soon as applications are deployed on containers, we get notifications and can tie them back to NSX policy. So as I said, you get the same level of services and operational model, which is very powerful, right? You have one network overlay technology for containers and VMs. The same rich micro-segmentation, plus consistent monitoring and troubleshooting across your environments by leveraging NSX. All right, so with that, I think I will hand over to Tina to talk about our NSX integration with Vcloud Director.
Thank you, Ray. So with all of the wonderful use cases that Ray talked about, right? But there is one challenge that service providers usually face when you're trying to offer the NSX, which is multi-tenancy. Like, as many of you usually have more than one customer, and then that one customer, or like they're usually not as big as like taking over the entire V Center or NSX. So you want to have those tenants now to share the same NSX manager or same the V Center. How can you give them the services and yet maintain the tenancy boundary, the tenant privacy and security, and also the resource isolation? And that is where Vcloud Director coming in. Vcloud Director has been supporting NSX since like 2015. So let me see, like show of hands, how many of you are using Vcloud Director today? Okay, good. I'm glad that you see that. Usually when I go into a different session, actually 2 years ago, I got a different that they think that Vcloud Director were dead. But thanks to you guys' support, now actually we are doing a lot more development on Vcloud Director. So let's get into that. Okay, as many of you know that Vcloud Director has been exposing a lot of the NSX function in a multi-tenant for both the API as well as UI. From the edge gateway, all of the function of the edge gateway, including from edge firewall, NAT, or IPsec VPN, L2 VPN that Ray talked about, the distributed firewall and security group, as well as the logical routers are all in a multi-tenant fashion. Every one of those functions is with the outback control. If the tenant pay you, you can give it to them. They can have a view only or a full access to configuration. Or if they haven't paid you for that service, you can just hire it from them, right? So it's like a really powerful way to give you a governance over your NSX. Then the second part is the tenancy boundary, which is a very important. As many of you know that, like the Vcloud Director, we isolated the resources into the virtual data center, the organization virtual data center. And that is sort of a logical sandbox that they have fencing from one tenant to another. And with that, they will have their own edge gateway, and also they have their own network pool, which is corresponding to a pool of the VXLAN. When you do the services on the edge gateway and also the corresponding network, which is passed by the logical switch, they only have access to the VMs within that particular VDC. That is how we can ensure there is no crosstalk from one tenant resource to another one. And also, then the Vcloud Director also do a lot of automation on your behalf. A lot of the tenants, they actually don't really need very complicated network topology. They will, first of all, they want to know how they will get to the internet or get to the WAN and what kind of services they're able. So Vcloud Director, we abstract a lot of those like most common network topology through one of these options. The first one is directly connected. That means you are not using any networking function within Vcloud Director. Maybe you're still architecting it outside of the Vcloud Director, maybe in the NSX or in your physical router switches and your firewall. That's fine. That is, we call it the directly connected network. Then the second one is the most common, which is like the routed network. That is, you have the logical switch connected to the edge gateway. Remember, all of the NSX gateway function is supported in Vcloud Director. Or routed network with the distributed routing, which is connected to the edge gateway with the logical router. And then the beauty of that is that all of those is connected by Vcloud Director, and you don't have to worry about setting up the control VM, running the dynamic routing protocol between the logical router to the edge gateway. Those are all done by Vcloud Director for you. And then lastly, we have two isolated network. There's no connection to the internet or to the WAN, maybe because you are running really sensitive workload there. And fast network are less commonly used, mostly for the lab testing. So those are all automated creation on behalf that you can use it or you can use the tenant to create for themselves. For the distributed firewall, which Ray mentioned, is a very powerful feature in NSX. But if you have many, many different tenants and then each of them have a lot of firewall rule, it can get really kind of complex to manage. Vcloud Director automated for you. First of all, if you have each of the VDC corresponding to tenant, will automatically create a session for you in the NSX manager dedicated to the tenant rules. And also, we created automatically a security group that is encompassing all of the VM that is in that VDC For each of the digital firewall rule created for that tenant, you will only be applied corresponding that security group to the VMs in that VDC. So you don't have to worry about the firewall rule created by one tenant will be internet on the workload of the other tenant. And if you go into the Vcloud Director UI, actually the UI just only give you the segment of the firewall rule for that particular tenant. So even if you have thousands of tenants, when you go into Vcloud Director, you only quickly find that one rule specific that tenant. And other new features that we are just coming in the 9.5, which we are launched in this VMworld and GA very soon after the VMworld, is the support of the cross VC Nsx in Vcloud Director. As Ray mentioned, multi-site is a very important feature for the service provider. Most of you have more than 5 data centers, as I did a last survey. So for the tenant consumption is that we make it a lot easier for you and for your tenant. You still have to select which one is your primary NSX, which one is your secondary NSX manager, create the universal transport zone. But then we have all extra things a little bit easier for you. Now, instead of you have to know, okay, this tenant has to be placed on this universal logical router, this on the universal logical switch, we take a tenant view. We now say, hey, for this, you have these alt VDC under this particular tenant. Maybe one in Vegas, one in Palo Alto. You add them into a new construct we call VDC group, which is in a sense that we build a universal logical router for you. We give you a view on that, okay, these are the edge gateway connected now on this alt VDC. Which one would you like to be the egress point? Is it active standby or active? And we give all those back into the tenant view so that they can visualize much easier. This is a screenshot of how it looks like. So you can see that you don't have to think about what is the logical router. Instead of, okay, I have 3 alt VDC, they now can be talking together through the cross VC Nsx. Then the second thing is that now we give them a topology view. Okay, out of these 3, now I have 2 possible ways to go out to your WAN or to the internet through 2 of the edge gateway. Do you want them to be active standby or the other active? So very easy selection for your tenant. And then lastly is that will be the stretch network. We don't call it the universal logical switch because it's a kind of really harder for the tenant user to understand. Instead, hey, this is the stretch network that stretch across all of your alt VDC. If you put your VMs on it, then the VMs can talk to one another, no matter whether they in the one site or across many different sites. And then also the last is that even for the IP address management across different sites, we will done on your behalf. Before, if you're doing L2 VPN, you have to remember to cover, okay, this top hub belonging to this site, this bottom hub put on that. Now we just say, hey, this is the pool, shared by all of that for this network, and then they allocate from that. Another new features in the VCD 9.5 is support of IPv6. I'm a little bit ashamed to say that we should have supported it a long time ago. NSX, V Center have been done it a while back. Now finally we caught up to that. And what we do is that you can enable the IPv6 on the external network as well as on the alt VDC network. Static routing, edge firewall, as well as the Nsx 4 are supported for your tenant. Okay. I hope that will especially make a lot of the Asia-Pac customer be happy. US a little bit behind, but I also see that IPv6 is becoming more popular in US. Okay, so now I have roughly about 5 minutes to go. Let me talk to you about, like, with all the NSXT function that we are bringing in, right? Now, if you are thinking about that, what will be the path for you to transition from V to T, or like just in a meanwhile, adopting it, try it out for yourself and for your customer? There are usually 2 ways to go, right? You started on this journey by coming here into this breakout, learning about NSXV as NSXT. So if you have a green field, maybe you never have NSX, or maybe you have a brand new data center, you can start with a green field of adopting NSXT. Or another way to go is that you want to keep your existing cluster, but migrate it from V directly to T. So Ray, what would you be recommendation for that if we want to do just straight up migration for that?
Yeah, so thank you, Tina. So I think one of the important points here is that we are, going back to the disclaimer, also working on a fully supported and productized migration capability. So this means that you can start with the version of NSX that's the right fit for your use cases today, and then that migration will be supported in two different modes, in phases. The first would be an in-place upgrade, where we actually retain your configuration, but in a maintenance window with downtime, upgrade NSX V to T. Or in future, we'll support actually a warm migration leveraging vMotion. So as long as you have additional hardware, we again will retain the configuration and reduce the downtime window. Yeah. So we see actually most service providers will fit into the coexistence category, yeah. Right? So that means they can actually start today and use the cloud management system to abstract the difference between V and T, and then just change over time. But I also want everyone to understand that we also are working on a migration path as well. So you'll all have a full choice and flexibility there.
Okay, hey, thank you, Ray. What we, in the meanwhile, as Ray mentioned, right, the migration tooling will be coming. But in the meanwhile, we would recommend is the coexisting, especially if you have a current customer on NSX V today, you don't want to disrupt their operation. So how do we do that? Actually, the easiest will be what we are recommending here. That you keep your compute storage cluster on NSX V intact, but now you also spin out a new edge cluster, your compute that is based on NSX T. You will be connected to each other through your layer 3, through your top of the rack, the physical network. At the bottom, right, to service your tenant once again, so to minimize the disruption to the tenant is once again by using a common cloud management platform. So it can be the Vcloud Director we just talked about, or even the vRealize automation. By both, the tenant, they still have the same point to access the workload. The network backing may be different, V to T, but actually the experience can be quite similar for the tenant and minimize their change in the operation for them. So let me talk about if you have like Vcloud Director, right? Coming in once again in 9.5 is that we'll support NSX as our first initial integration. So with the Vcloud Director, same Vcloud Director, we can support both V together. And the only thing is that they will be separated by different cluster. In the Vcloud Director speak, we call it different provider VDC. So one can be backed by NSX V with the V Center. The same V Center can also be used to support a PVDC backed by NSX T. So that gives you a lot of flexibility. With that first initial integration, we can only support it directly to connected network. That means like most of the edge services and then configuration has to be done by T in the Team Manager, but you will import it as a network into the Vcloud Director. But one thing that we're trying to address is that, as Ray mentioned, of the high performance, the enhanced networking stack that is based on the DPDK, we will support that mainly for the high performance, low latency node for the telco and FV use case. Okay. So with that, now let me go into, right? So if you are using Vcloud Director and want to adopt the NSX as a coexistent, what you do, you have to do all the backend management. You have to first install the NSX Manager, of course, and then for your Vsphere, for your compute cluster, right? Make sure that you're running Vsphere 6.5, or even better yet, like 6.7. You create a compute cluster that is also add that into NSX Manager. Instantiate your switch, whether it's the regular NVDS or the ENS switch, and also create the edge node. Then now upgrade your Vcloud Director to 9.5, register the NSX Manager. So that is really important. Before, that was like a one-to-one relationship between V Center and NSX V. Now, because like the NSX, while it recognizes the V Center is not like directly tied, make sure that you register the NSX Manager separately. And also now create a PVDC that is by your new NSX Manager and then your V Center. Now, going in that, right, you still have to, for your tenant, you have to create a new alt VDC placed in that new PVDC that you just created. Then now you have to do all of the networking for now in the NSX manager, create the logical router and with the T0 or T1, and then logical switch, import it back into the ECD. Now, after this all done, a lot of steps, but by the time they do that, the tenant, all they see is just a network. So will be a little bit fewer service for them for now, but then they will just consume it pretty much the same as before. And we do have plan in Vcloud Director in future releases to support more and more function natively and expose them in a multi-tenant manner, just like what we did in the NSXV. Okay. So with that, I mean, we are coming into the end of the presentation. I would like to just do a summary, quick summary on that. We cover a lot of the NSXV and NSXT and also use cases. And you can see that with the NSXT, we're expanding into the NFV workload with the high performance, low latency support of the DBTK switch, as well as like for the container support. Vcloud Director 9.5, we added more multi-tenancy through the support of the cross VC networking, the IPv6, and also the NSXT initial support. So with that, we want to bid you well on your journey, or whether you are continuing your development on the NSXV, or you want to start adopting NSXT. If with that, like we still have 3 minutes. Is there any kind of question you have? Yes? Can you so your question is that is the L2 VPN is up to 1.5 gig?
Yes, so the throughput per tunnel is 1.5 gig using our extra large edge form factor. So that's actually one of the differentiators between using a VPN-based approach or cross VC NSX is the performance requirements. Because the data path has to go through edge devices, it is slower than using a VXLAN natively. Actually,
Ray, can you repeat that?
Yeah, sorry, the questions are a touch hard to hear. So one was about, I think the first was about the performance of L2 VPN. Second question was about the maximum throughput that we get and whether that's because it's single-threaded. So actually, if you choose quad large or extra large edge size, we'll actually dedicate a CPU core to the L2 VPN. But yeah, it does only use one vCPU from the edge. Yes, that's correct, yes.
And we have a question here, yes.
So, question I have, so reading between some of the tea leaves, at least what I'm kind of hearing without what you're saying without actually saying, is that we are at an inflection phase where you're actually going to be, over the next, say, 5 years, transitioning from NSXV to NSXT, just like we did the transition from ESX to ESXi. Am I hearing correctly, or is that something you can't comment on?
No, I mean, look, I think we're continuing to develop both platforms, right? Over time, absolutely. We want NSXT to support all of the functionality that we have in V. The good thing, though, is in these service provider use cases, right, you can offer both. You can have NSXV-backed clusters and PVDCs providing multi-site rich services, partner integrations, and support some of these new use cases like NFV or containers, and then just transition over time. So yes, over time, you'll see more and more features added to NSXT, but the good thing is you get choice. So.
Okay, so I think we are really reaching the top of the hour. Hey, thank you for coming. And then like Ray and I will stick around if you have any other question. We are welcome to like come to us and we can discuss in the hallway.
Thank you, everyone.
Thank you.